Okay, so let's talk about the algorithm of deep reinforcement learning, or specifically if we talk about DQN, right? Deep Q network or deep quality network. So most of the things are almost the same that we have already implemented in Q learning or in SARSA. I mean, structure of this algorithm is pretty much same. There will be a little bit of new things since we have added deep learning into it, and let's talk about them. So first of all, we will be initializing a policy network. What is a policy network? I've already written it in bold letters, so that I mean, it means that we are going to learn about it in a while, so you don't have to be worried about it. In short, policy network is nothing, it's just a neural network, right? It's just a simple neural network that has some responsibilities. That's why we call it a policy network. Then we create a new network called target network. It is again a simple neural network that will be a replica of policy network, right? We will be implementing it in a while. Then we will initialize a replay memory. This is a new thing. This is a new concept, and the whole concept of deep QN, it circles around the replay memory. We'll be talking about replay memory in depth. And then there will be a for loop. Obviously, we always have a for loop for each episode, right? If you remember. And then we will initialize the starting state. Obviously, we reset the state, if you remember, right? Then for each time step, like for each step, right? Um, I hope you're recalling it now. There is an outer loop for the episode, and then there is an inner loop for the number of steps, right? And then we select an action via exploration or exploitation. You guys already familiar with it. Then we execute that selected action via gem, the gem environment. I mean, this is not a part of a general DQN algorithm, but this is a part of algorithm that we'll be implementing in our course. So somehow if we talk about a general implementation, somehow you execute the selected action in your environment. If we replace this gem with environment, right? You execute your action in environment. In our case, we will be implementing it in gem. So then what we get if we execute our action, what we get in response, we get a reward and a next state. We have already done that. Then we store the experience in replay memory. Okay, this is another important thing. If you recall the step number 3 over here, this replay memory. Okay, so imagine this replay memory is sort of a human memory, right? So you store your experiences in your memory, in your brain, somewhere in your brain. So in these three steps, you will be having some of the experience, right? You have executed an action, you've got some reward, you've got a next state, right? So this whole thing is an experience for you, right? So let's list it down. So let's say you previously you had a state, let's call it S. Then you executed an action on this state, right? So in return you get some reward, and then again you get a new state, let's call it S dash. So this whole thing is your experience, right? Let me call it EXP. Right now, that's about it. We'll be talking about experience and replay memory in detail in upcoming lectures, right? So when you get all these things, you get state, you get action, you get reward, and you get the new state. You call it an experience, and you store your experience in a replay memory, or you store it in a brain if we relate it to a human being. Then we sample a random batch from replay memory, right? So imagine that in our replay memory, we have a lot of experience. We have, let's say, tons of experience. So we get a random batch from the replay memory. We pre-process this batch, right? The states, these states that we have stored in it, right? We pre-process these states from the batch. Then what do we do in pre-processing? It really depends upon the nature of data. Since we will be working with the pictorial data, or you can say the graphical data. So usually in graphical data, we grayscale the image, we crop it, we scale it, and stuff like that. If you're working with the statistical data, then the pre-processing steps will be a little bit different. Then we pass that pre-processed batch to the policy network. Remember this policy network that we talked about it in the beginning? It's just a neural network. So we pass that batch to that pre-processed batch to the policy network, and then we calculate the loss between Q values and target Q values. Now this is another tricky thing. I'll not talk about it right now. Just imagine these Q values are coming from policy network and target Q values are coming from target network, right? Target Q values refers to target network and simple Q values refer to policy network. Right now, just get this through your head. We'll talk about it in depth later on. Then we update the weights by using gradient descent in policy network, right? To minimize, obviously to minimize the loss. And what would be the equation in order to update the weights? We'll talk about it as well. And finally, after some timestamps, we will be, X timestamps. X is sort of hyperparameter, not sort of, but exactly a hyperparameter. So after X timestamps, we will be copying the weights of policy network to the target network, right? Why do we do this? I'll talk about it when I'll talk about the difference between policy network and target network. I hope this whole algorithm is not very much clear to you guys right now. I'm really hoping that. The point of discussing this algorithm is just to have a quick idea about the goal, about where we want to go, about what we are going to do in this module. So all we are going to do in this module are to cover these steps practically and theoretically as well. So see you in next video where we'll be talking about policy network, and then we'll talk about the target network.